Hello, my name is Radomir Dopieralski and I'm going to talk about several things that I think make a better programmer. It's about tools, so probably many of you already use those tools, but many of you and people who will maybe watch it are not using them, and it's a great shame because they really make your program better. It's about two kinds of tools. First is the version control system, and it really changes the way you think about your code. It's not just that it's comfortable, because it is comfortable. You don't have to worry about losing your data. You don't have to worry about commenting out code and removing some code and losing it, or changing some part of your program and then not being able to come back to it. Many times I've seen in sources huge batches of commented out code, and I think they are ugly. They make it harder to read that code. And I think they are there because the programmers are afraid to actually delete that code, because they think they one day might need it again. And if you use a version control system, you don't really need that. You can go back to your old code at any time. You can go back and see how it worked before. You can go back and compare your new code with the old code, for example, the performance of it or the results of it, and without having to make a copy in advance, because, I don't know, you make some change that you didn't think about before, and it turns out to be a huge change. You didn't plan it to be a huge change, and then you finish it and you want to see if it actually is better than it was. So you can go back to any point in time. The second advantage is that you don't usually test all your programs completely after each change. And sometimes there are places that interconnect with very far and distant areas of your program, and you usually don't test those. When you do some change in your display code, for example, you don't test your character generation code. And sometimes there is some problem with that, especially in dynamic languages like Python or Perl or things like that mostly have runtime errors. And then suddenly you have error. Your code is broken, and you don't remember what you changed to cause that error. Then you take your version control system, you browse it, you see when that line was last modified and what part of what change it was part of, and you have much better idea of what went wrong. And the third advantage, and I think this is the greatest advantage of version control systems, is that they usually require you to type some comment about what you change. And this thing has psychological effects, because, okay, for the first 10 commits you just type whatever, or I changed something, or another change, or another try, and things like that. But after a while you start, it's getting old. You start to actually think about, okay, I will have to commit that change that I'm making now. Maybe I will just limit myself to doing one meaningful thing, because I will have to describe it later. So I will just change that little thing, and I won't touch the code that's next to it that I want to change next. I will commit and change it in a separate commit, because then it gets easier to describe. And you start making changes that are easy to describe, and coincidentally, changes that are easy to describe are usually also easy to understand. So you start making small changes that are easy to understand, and it's much easier to follow your code. Your code gets cleaner, and you yourself have a much better history of your development. Okay, that's about version control systems. And the second thing that...
May I?
Okay.
I didn't know if you said it, but one of the beginners' mistakes they make is to commit large chunks of code.
Exactly.
They should always commit small changes, so first you can see at a glance what it is that was changed, and if is a mistake in there, you can easily revert it.
Yes, another thing is that you usually commit complete changes. Not necessarily, well, in small project that means you commit working code. In larger projects it's not always possible, especially if you are doing some large refactorings. But
if you're working with other people, it better be working code.
Exactly. Then you commit complete changes. It may be changes in different files. For example, if you change your API or something in the interfaces. But it's semantically one change that's described with this commit message. And I think it's committing small changes. It comes with experience with using version control systems, exactly because you have to describe them. And it's easier to describe a small change than it's to describe a huge chunk of data. What you say about committing small changes, I think that distributed version control systems have a great advantage here. Because people often are afraid to show their code. So they will stack, keep the changes, not committed, because until they are complete or until people think that they are nice enough to show to other people.
Yeah.
So you keep procrastinating the commit, and it grows really large.
Yes, there is no monolithic version control system that really does easy branchings.
Exactly. But when you have a distributed version control system, you make the commit, but making the commit doesn't necessarily make it public. So you make small commits, and then you decide when it's shaping up nicely, you decided to push it to the central server, and then it's published. So this is, I think it's an advantage of distributed version control systems.
I think the main point here is not the public versus private, but how easy it is to branch it off to not to the main trunk, but to your own personal trunk.
Well, that depends on how you organize your work. I suppose that there might be something in that, because with distributed version systems you are automatically working on your own branch. Always. So there may be something in that. Another tool that changes how you think about your programs is testing framework and actually writing unit tests. Unit tests are all the rage now, and they are becoming very popular, especially with the more dynamic languages that make it where the compiler doesn't catch all your errors. Then you have to write some code to catch those errors for you. And once you do it, you can also catch logic errors or design errors and all the stuff that the compiler has no chance of noticing. Once you start writing unit tests, especially if you start, well, there are several kinds of tests you can write. I will maybe say that there are acceptance tests where you first you get a specification from your client, for example, and you write tests that test for that specification. Or you decide on something that's, well, for example, there must be something must be displayed in this area of the screen. So you write some test that actually maybe takes a screenshot and checks if there is something in there, or uses some inspecting library to check if there is something in there. But the acceptance tests are very high level. They check how the program works from the user's perspective or from the system's perspective, but they don't check how it does it internally. On the other side of the spectrum are the unit tests that usually test a single function in your code. So you decide that this function is supposed to do this and this, and then you write a test that only checks if this function does what it's supposed to do. Acceptance tests are great for making sure you are really reading what you are supposed to write, and unit tests are great for catching errors like the compiler errors and I don't know, wrong operator used somewhere or something like that. There can be also a whole spectrum of tests in the middle that, for example, check for I don't know, only map generation or only character creation. The point is, if you start writing unit tests, those are the ones that test single functions, and the recommended way of writing them is to write them before you write the function. You first have to think what this function is supposed to do exactly before you even start writing your function. And because you have to write a test for it, you have to actually use that function in the code of your test before you have the function. So it has to be testable. Because you write the test, you want the function to be comfortable for you to call and comfortable for you to check the results of it and stuff like that. So you actually think about the API more. You design a better interface for that function. You often isolate the function. You initially, for example, you initially think of some function that does a lot of stuff, but then when you try to write tests for that, you realize that wait, this would be much easier if that function only did small thing. Or the other way around, you have some small function that only does something ridiculously simple, and you write a test for it, and you think, wait, I don't have to test it. It's obvious that it will work. So I will put that function in some larger context because I don't need to test for that. And similar to how version control system changes the way you think, because you think about the change you are going to do, unit testing changes the way you plan for small pieces of your code, because you are lazy. You want to write, if you have to write the test, you want them to be simple to write. So you have to plan for them. And all this thinking, at some point you start to do it automatically. You don't really have to sit down and think about how to test it. You get some reflexes and start reading better code. So I think that's it, and I hope that somebody will benefit from it. Any questions?
Yeah, so which distributed version control system would you use as sort of, single man working on a project? So I tend to use Subversion, but obviously it's not distributed, and sometimes it's used to get somebody else in.
Can we make a survey out of this? Who of you is using unit tests, and what version control systems are you using?
You asked two questions.
Yeah, exactly.
So, who's using a version control system at all?
So that's everyone.
Everyone.
Okay, so what kind of Unix version systems do you use? Maybe?
Mostly Subversion, a little bit of Mercurial, and it's one Git. Yes.
I just use Subversion.
Back in the Middle Ages, I actually started using RCS, which has...
Oh, I have to use RCS.
No, yeah, it has the unique status of being a version control system which is worse than CVS.
I switched to CVS.
Yeah. And the reason why I started using it was that I could understand it very easily how it works. You know, you have a plain text file and it lists all your changes and when you did it and so on. So it's there's very little abstractions there. You see exactly how it works. Of course, it didn't last for very long because it gets unwieldy very, very quickly. And then I switched to Subversion, which I was quite happy with. I was happy with it mostly because I was the only person working on it and I didn't have to merge anything. Because merges in Subversion are, if they're non-trivial, they're almost always manual. You almost always have to do it manually.
They're better than CVS though.
Yeah, that's a very small phrase. Yeah, then I've switched to Git maybe a year ago, and well, to tell you the truth, as a single developer, I did not see a huge advantage in using Git because, as a single developer and using a relatively small code base. Because Subversion for small code bases actually can do branching and stuff like that pretty quickly, and you can merge from one branch to the other relatively quickly. I mean, Subversion is significantly slower than Git, but for small code bases it doesn't make that much of a difference. And being a single developer, I don't really need to merge very often. And one disadvantage of Git is that I find one of them is that the command line interface for it, the default one, is not very user-friendly in my opinion. It has, I don't know, it requires you to use more commands than Subversion does, and
it was designed by pair programmers. What could be wrong?
Yeah.
With it?
And the second thing is that I don't like it is that the GUI interfaces for it are also significantly less user-friendly than Subversion's. So I've actually switched back to Subversion after a few months with Git, and that's what I'm still using now.
You said that working with Git didn't have, you couldn't really exploit the branching features that are easy with it.
I could, but branching, when you have a project that you're the only person working on it, and that is not hundreds of megabytes of source code, and that you know quite well, branching in Subversion is also quite easy.
Yeah,
and merging it back into the main trunk.
You just copy it.
And
It's just huge network file system with version control.
After I started using distributed version control systems, as usual, I had this experience years ago with better programming languages that's built back in the less good programming languages like C, for example. And with version control systems I had the same experience because I started to use a copy, a non-branched copy of Subversion checkouts and called them Playground, and there I would do something and maybe let it sit for a month or so and then do it again and afterwards check in or not. It is a problem that branching is highly costly in Subversion, so we don't do it a lot. But if you just tingle and tweak some little things that are not don't get to be large commits, then I now do prefer to do them outside of the main trunk.
okay.
So I don't have the. Usually it's things where I have to this would be a nice idea, let's try it. Okay, I have to change, let's say, 50 lines, but it didn't work 100% correct. And then I let it sit and let it sink, and then a month later I tried again, and then I could do, if I test it this way, I see what's wrong, and then I can do it right and check it in.
Yeah, I think it's correct. I think the main idea here was that I couldn't see the real disadvantage of Subversion because I'm so used to working on it, and I'm not used to working in a better system, which it might well be true, and maybe I didn't give Git enough time to explore all these more advanced features.
You could try Mercurial, that is much more like Subversion, although it has other problems compared to Git.
It has pretty... you can learn to use it very fast.
Yes, the commands, 6 or 7 commands that almost work like in Subversion.
Yeah, I'll give that a try.
And you don't need a server, you can have it locally. If you want to really feel how a distributed version control system works with branching and all that, Mercurial is a good tutorial.
Yeah, okay.
Okay.
I use Subversion. I'm pretty happy with it because it's really simple. Usually I use only 3 commands or 2. Commit and up, yeah. So it's 2, and it's unfortunately it's painfully slow in SourceForge. It's sometimes it takes up to a minute for a commit. So it's
that's why I have my own personal offsite Subversion repository. I got one of those really small little network appliance type computers and off compact flash only. So.
Before I continue, do you think people will be able to hear if he's behind the microphone? Or should
I don't know. So yeah, it's just around. And actually, now that the not pointing at me, people can't hear me. I kind of like the monolithic Subversion type stuff because they have a authoritative push system, which I know has my right copy, which is distributed. I don't know. It's like I'm sure you can work it out the same way. It's just nice a star approach.
It's a bit like a difference between how France has a government compared to how Switzerland has a government. One is centralistic and one is totally distributed. Both work in some way and some don't.
If it's governments, then we know none of them work.
I think that actually version control system is in large part a question of personality and of style of work, because different people prefer different things.
Or worse, management decisions.
Well, that also happens, but we are talking about the perfect world of roguelike development.
Yeah, our managements ourselves. Yeah.
Well, one advantage is if you are distributed, you know no bad programmer can fuck up your repository. You can commit code that sucks.
If you let them push into your repository.
Yes, but then
you don't give push rights to everybody.
But then you can easily revert those things. If you have a central one, you also have the power to really say no, we don't like that. But
well, I
yes.
think it has this cherry picking thing too, so where you can import only some changes from a second clone of the repository. Okay.
Anyways, next on, do you have more to say?
No, I wanted to say something about Git. I truly follow Ido's opinions because it's painful to learn, and somehow it's the revision numbers in Subversion are very easy to understand. You just add one and it's the new version, and in Git you have these obscure unique identifiers which tell you nothing about what it is.
Yeah, when it is, and like when we have with work where we have Subversion, and the bug database can tie revision numbers to that, and it's you can tell what's later and earlier. I like the global unique revision numbers; they're simple.
I also use Subversion mostly, and I'm thinking about using Git, and I I think it could help me something, but I think it's not still as comfortable to use the GUI clients, and so I am observing it, but it's not yet. Okay.
Well, I should be telling you a lot because Crawl recently switched from Esperanto to Git. But the problem is I'm not actually involved in this at the moment because I took a time out for my bachelor's thesis. So I've seen a lot of what they're doing. I'm also really confused about the version I'm running. But I haven't actually tried to pull anything or commit anything, and so I only see the bugs we are getting and the discussions. And the discussions are quite intense because obviously everyone has been working with Subversion for a while and everything worked mostly. And the problem of Crawl is different than for most of you because we are a large project. We have around 10 or so official developers at the moment, and well, we wanted to get more patches because it's getting really big and we've got a lot of stuff to do, and so we are pushing a lot of stuff to players because they want to do something and we want them to do something, and that was really difficult with Subversion. So we switched to Git, and we got a lot of patches, and I mean we've got 6 new developers that way. That's, I mean, really half the team. It's just it's going to double in a month. So obviously it's very, very popular, but for all of us old developers, it's a lot of change, and everyone has problems, and then someone accidentally clears the whole repository and whatever. You know these things happen, but we're slowly learning. And when I get back, I have a lot. Everyone will be able to explain everything to me. It's a good thing. But I think for big projects, it seems like a good move.
We'll find out in a year of Crawl switches back to Subversion.
Cam's pointing roughly at me. Yeah, I use Subversion. I've never really been brave enough to try merging branches, but you claim it works. So probably what I'd like to try Git or something where it's repeated to work a bit better. I think one of the great things about version control compared to before I started using it. Before I started using it, one of my projects, you know, say Space Game, would be Space Game 1, Space Game 2, Space Game 3 directories up to about 20, some with different names that aren't numerically ordered. I'd leave it for 6 months, come back. I have no idea which is the best up to date. So.
I actually had a target in my make file, make backup, that would tear up the whole source tree with a date in the file name.
Yeah, so there's a lot of good things about source control.
Oh yeah.
Yeah, I have 2 points of view here. One is here from work, where we have a kind of peculiar setup, because we're using CVS as a central IT managed solution, so every project at CERN is using CVS. Now, the whole world is switching to Git, so of course our IT system is switching to SVN. So, what people do here is all the teams, so that's about 7 to 8 people per team, are using Git internally, and only when they finish a release that they want to push out, then they sync that stuff into the centralized SVN to have the backups. So no one messes with the SVN of the system here, because it's just too convoluted. You have, I don't know, 400, 500 people trying to commit at the same time, and it just stuffs up. So
this way you get the best of both worlds.
yes, and this is great because some decisions are not that great concerning APIs, so people just go on, they hack a little bit, and with Git it's just great just to branch off a little bit, try it out, and then merge with other groups. It's brilliant to work with. And once you've converged, usually there's 3 or 4 groups of 7 people involved who have to figure out how to get the APIs right.
Until
once that's finished, and then it just goes to the central repository. And since I've been using Git at work basically daily, the whole way of thinking changes. So even at home I use Git as a single developer, and if I want to make a new feature in my code, I don't just do it on, well, head. I branch, I do the change there, I tag this one and then only merge it back to the origin master. And so I basically have for every change that I do, I have its own branch. So every feature is a single branch. And with Git, that's you can merge it wherever you want. This is just it's kind of component building the source code inside the version control set, and this is working brilliantly. And well, if you're used to using Git every day, it's
easy.
Yeah, it's.
You do not use it. But the system you described, that there's a central Subversion repository, and you have your own Git world within your team. I'm thinking it must be a lot of fun when somebody changes something in the Subversion repository before you've done changes to the same files, and then you have to merge it manually.
In that case, we have basically librarian kind of people who take care of that. The build fund for the analysis release here is I don't know, 90 machines or so. They're all quad cores, and it takes 12 hours to build the complete analysis of the release. So these people are full-time working on just doing releases.
Okay, about testing. Who of you have ever written any unit test?
Ever, okay.
Ever?
Yeah, ever,
That's easy.
Okay, who of you
write unit tests?
have ever wrote any unit test before reading the code that is going to be tested?
That's all unit tests for the grammar framework of NetAct.
Nice.
But you did not write it 25 years ago.
No.
Before, who of you have written a unit test for a function before reading that function?
Usually, that is cool. I would ask, how often do you do that? Not have you ever?
No, let's have you ever first?
Yeah, I think I have once.
Statistically, you must have maybe done it once by accident.
Okay.
I might ask you, because I've originally learned programming with Lisp, and Lisp is a language that basically forces you to think of the API first, so it's kind of writing the unit test in your head before actually writing the code, because otherwise the language won't work. So I don't know if that counts for a yes.
Who of you does it, I don't know, on an everyday basis at work?
No.
Well, I don't know, like my compiler's my unit tester, so...
Yeah, it has unit tests.
Yeah.
It checks for type.
Checks for type, and you can install, like they showed with Haskell, you can do a lot of programming just with type language in it. So
there are those
proofs can be done
linked applications too that do some testing. You can specify some requirements for them. There is Splint, I think, for C, and that's it's an interesting program. You add annotations in comments in your code that, for example, specify that this data structure is being owned by that data structure, or things like this variable should never, this pointer should never be null, and things like that. And Splint does static code analysis and finds, it also checks for boundaries of things and things like that, and it really changes C from a very sloppy language to a pretty strict and nice language that's horrible to write in. But once you write in it and it compiles, you know that there are no buffer underruns, overruns, and no off by one error.
But I get most of that with C++, because you can, it has a stricter typing on it, and then also you can start, having data structures that don't let you do buffer out of.
So I think the main problem here is Splint gives you so many false positives that it's basically
Yes, it's
unusable.
only useful for small parts of code, for kernel modules maybe, things that
Yeah,
you really need to have secure. It's called security protection links.
Yeah, it's
so
like we have to turn off, like there's the use of uninitialized variables in GCC we have to turn off because it's too many false positives. So just rely on the Microsoft compiler for those.
And you need annotated versions of the header files for it. That also sucks.
I think if we can, this is actually something I disagree with, and it's actually the same thing with unit testing. What you're saying, both with using more stricter language or turning C into a stricter language than it is, and writing unit testing, I think this is something that every one of us who has worked in an enterprise environment where you have 10-year-old code written by 50 people that has really centuries of man-years invested in it, probably all think or all get the idea that it's good because you know when you have to debug somebody else's code that haven't been there for 5 years and it does something stupid, then it's a pain in the ass. But I think when you're writing a game as a hobby, the main risk here is not that in 5 years it will not be maintainable, but that you will abandon it in 3 months because it's not fun to work on.
Well, I recently came back to a game that I wrote 6 months ago, and I really had to learn it from scratch.
Yeah, no, I'm sure there are cases where it's not like a black or white thing, but I'm sure there are cases where investing a lot of time in advance to write code properly pays off. But I would say, at least from my experience, it's
I mean,
not
the advantage of reading unit tests, the advantage that I advertise here, is not that you have a tested program, because that's useful in as you say, corporate work or something like that. It's not necessary for a game, but the advantage that I advertise here is that you change the way you are thinking about your code. So it's more psychological thing than you know.
The most satisfying effect of writing unit tests is if you have a framework that shows you if your unit tests run through, and then you write a new unit test for the feature you want. The IDE shows you a red light. Then you start coding, and as soon as it pops to green, you know you are finished.
Yeah, and you leave it.
Yes.
You don't do anything more, well, maybe some refactoring.
But it's also that for a language like C, it is harder to write decent unit tests. Yes. Because it's just a patch on the language and it's not integrated, and it's ugly. Yes.
And I think also the trouble with C and C++ is they're not as necessary. Yes. So, because I know working with Python, I can see why Python developers start talking about unit tests all the time.
You need to execute at least each part at least once.
Executed once, yeah, because otherwise you could have a runtime error. And you grow this whole blob of Python code, and you can change an API somewhere in there. There's no way to tell if you've now broken other code, and it's without running unit tests.
Yes, but it's also a compiler can only test so much, not everything. And when I do work, when I do, well, it depends a little bit on the language. In Eiffel, you can test, the compiler can test way more than a C compiler. Recently they got a new feature called nullables variables, where you declare a variable, this one may become null, and the others don't. So as soon as a null pointer gets assigned to a variable that does not may become null, boom. So
ever programmed in Ada?
Yes.
Worked on an Ada compiler.
Yes.
Sometimes working in Rails, for example, is also fun because you have so much support from the framework to do those unit tests and those functional tests. It would be madness not to use it. But in C, you have to get your ass off and do it. That's for lazy programmers.
Which comes into the, if we're going to complete the game, I'm not going to do that.
Yeah.
So.
Anybody of you have worked in a project that has, I don't know, maybe full test coverage, maybe 90% test coverage?
Not one.
Well, basically what we do here is fully unit tested. It's completely written in Python.
Yeah.
And the big problem here is actually not unit testing the software itself, but making sure that the third-party stuff we depend on, like the grid libraries and some mathematical functions from Fortran or some other obscure libraries.
So you have to black box test
Yeah,
external libraries.
That's a real
horrible.
pain because just checking your own code, you can write unit tests for your own code,
Yeah.
but you cannot write a unit test for a third-party library that
You
don't
need
have.
acceptance tests.
It's a nightmare, and especially when you run into obscure 64-bit, 32-bit bugs.
But the first time I actually wrote some code with unit tests, the tests weren't mine, it was some competition, and the unit tests were provided as a guide for what's expected as a result. Of course, the exercise was described, maybe we'll leave it here. So the competition, I think it was hacking for a keyboard. So the task was described, and you also had a set of unit tests for it. And reading the code, and the goal was to get the shortest possible program. And reading with unit tests is so nice because you don't have to think. You just try random stuff and see if the test is
That's a strong argument against unit tests. Because that same argument once was given of why a real programmer never uses a debugger.
Yeah.
Is if you use a debugger, it means you don't understand your code and you can't. And A, you wrote it wrong in the first place, and B, you didn't immediately know what was wrong when you saw the
Of
file.
course, but well,
Because it's like if I say I compile until it compiles and then I ship the code. It's like, no, I should actually run it and see if it works, right?
yes.
It's like you put all your faith in the unit test.
Then again, in the real world, you get a code base that's just reading that code base would to take you 6 months,
Yeah.
and you need to change some small thing in it. So, if you have unit tests, you just change it and see if anything's wrong.
But something might have broken and your unit test.
Then you have wrong unit tests.
But is there any unit test in the real world that is not wrong in some way? I mean,
There are unit tests for the unit tests.
See, my experience is I get the code and I may or may not get unit tests which I know will not have complete coverage, so I need to write the fix and also make sure it sort of integrates as sort of a new test afterwards. I don't know, that's my trouble with the pre-testing. I don't know. And validation.
When I have usually I don't write tests in advance.
Yeah.
But I write my application, and when I catch myself that I'm doing some change and then doing some testing, manual testing, and I'm doing it for the 3rd time, I know it's time to actually automate that, so that I can save some time and actually do some coding instead of repeating the same, especially with games where you it gets addictive to play your own game at some point. And, well, okay, it's fun, but at some point you want to save some time and actually automate some tests. And it hurts when at the point where playing your game starts to take a lot of time, your game is so advanced, so large that's not really, that it's not really easy to write tests for it anymore. If you wrote tests from the beginning, they would grow with the game, so there would be no problem. you would have some API to access the internals of your game. Maybe text file saves. That's nice too for testing. You can then just use grep for checking if there is the expected thing in it.
Just out of curiosity, because I guess I was a bit too aggressive with the way I said it. Because obviously, like, having unit tests is better than not having unit tests. It's a good thing. It's just I worry that I would become lazy and run the unit test, and then discover after I shift.
It's the same with debugger. Having debugger is better than not having a debugger.
Exactly.
But you don't use debugger all the time. You only use it when you get stuck.
Can I just show some code here from work that this is my favorite example for why you should have unit tests.
Okay, let's.
And don't worry, this is actual code that's in production use and is analyzing LHC data.
Good thing it's not controlling the LHC.
Yes, yes, yes. It's Python code, so it should be quite easy to understand.
Especially for non-Python programmers. Because as we know...
My grandmother could understand Python.
Python was designed to be understood by non-Python programmers.
Can you see? Okay, that's a run transform, which basically generates analysis job descriptions. So, and I'll just scroll through it. And it's a huge bunch of completely undocumented ifs and fors.
Python, the basic way.
It goes on like this.
Strings there.
Yeah, and then there's fun stuff like this. bpath, so blah blah blah. If bpath last entry does not equal X,
I noticed that mathematicians tend to use single letter variables.
Yeah. What the fuck is this?
Didi. For Didi, yeah.
And there's a classic. I'm trying to find it. Ah yeah, get CPU speed. So, well, let's just pass proc CPU info, and that's actually how the scheduler works. So
How much work is it to maintain those unit tests? I always
there are none.
So, no work at all.
Because no one could ever write one.
Yeah, I think my code base always moves, I think, much too fast, and if I change something, the changes are big, and if I had unit tests, I would have to rewrite all unit tests all the time.
No, that's another thing that changes. You stop making huge changes to your code.
But I...
That's the sort of trouble. Then you change how you program a different way. It's like
not the thing I get paid for.
I'm trying to find that part. There actually is a piece of code that goes through a string and checks if it's of a correct format. And if not, it accepts and goes through some error checking routine. And it can fail there as well. So you actually get the output that error was not even successful. I don't know.
It's a classic. There was that Windows message. Error in the error reporting, there is no such error.
Yeah. Yeah, well, forget it.
By the way, Jacques just emailed me and said he also missed his slide.
Who?
Jacques van der Merwe. He's actually Swiss, but he is apparently now stuck in Tel Aviv airport. He missed his flight, so he's not gonna come.
He's stuck in Tel Aviv.
Yeah,
It's a bit of a wrong turn, isn't it?
that's what he wrote. So
I thought he was a South African living in Switzerland.
he is, but apparently he's now in Tel Aviv, stuck in the airport.
Right? Okay. So any more comments? Otherwise we would suggest we grab some coffee.
That's it.